Good morning, students. We will continue chapter 2, physical quantities and measurement. So in this chapter already we have discussed about what is measurement. Measurement is basically a process of comparisons. About the units we have seen, like some basic units: length, mass, time, temperature. These are called SI units, which is standard, stands for standard international unit. Then after we have seen how to write the units. There are some rules of writing, the conventions writing the SI units. Suppose that we are writing in a short forms. So if it is a normal name like meter, kilograms, so we can start with the small letter, but the same unit but name with the scientist, like ampere, like Newton. So whenever we write in the small letter, when we write only the short forms, so we have to start with the capital letter, so that we cannot use the plurals with the unit names. So suppose if you write the full name meter, metre, likewise, or like a kilometer, so in that case always we have to write in a small letter. Even if the name of the scientist also, like Newton, so not capital NEWTON, it will be small n e small n e w t o n, Newton. So likewise we are writing the there is a rules for writing the SI units. Like for the Newtons, as I said, that NEWTON, it will not capital N, it will be small n. So then after we have seen about the first basic units which was ours, measurement regarding the length. The first one was the length. So length is the distance between 2 points. Already we have discussed about this. So in the length, to measure this length, we have two devices we have. So first was the meter rules and second was the measuring tapes. So we have covered about the meter rules. That was your simple scale, the plastic scale which we used. So that is of about 15 centimeter and something like that, based on the length, the whatever you use. So that the use of the meter rules that we have seen. So with this meter rule, as you see that 0 and 1, so in that markings are there, then after 2, then after is the 3, likewise. So in between you have noticed that there are some small signs are there, small gaps are there, and this is divided into 10 parts. This is divided into 10 parts, and each one part will called 1 by 10, and this 1 by 10 is the 1 millimeter. So 1 by 10 of 1 this is the 1 by 10 of 1 centimeter, which is the 1 millimeter. So it means what we conclude from here, with this scale we can measure the minimum. What is the minimum length that we can measure? That is only 1 millimeter. So below the 1 millimeter we cannot measure, like 0.5 millimeter or 0.001. So likewise the below 1 means the below 1 millimeter we cannot measure with this our normal scale, that is called meter rule. So for that we have to use the different type of scales. So about that we will see here. So that is not in details, you have to know about that, only the names you should know. So there are two types of we have, which is the first one is the vernier calipers, which is used to measure the length up to 0.1 millimeter, right? And we have the screw gauge, and this is used to measure up to 0.01 millimeter. So this is the also type of scale. So this scales we should know to measure the precise value below the 1 millimeter. So we can use this vernier calipers and screw gauge. So now today we'll see the other part of this, which is the use of measuring tape to measure length, right? So now we can, the first device that we have used, meter rule, which is the plastic one, to measure the length. Now we have using the tape, and this tape, what is the benefit? It is a flexible ruler. Okay, so flexible means we can bend it, because as you have a plastic scale, can you bend that? Can you measure the curved length? You cannot. Only the straight lengths you can measure out. So to measure the curves one, like suppose this is the straight one, so you can use simply your scale and you can measure it. That was your meter rule. But suppose that this length you have to measure. In this case, can you measure this by your simple meter rule? The answer is no. So for this you have to use the measuring tapes, which is the flexible ruler. So it consists of ribbon of cloth, plastic, fiber, glass, metal strip with lines of marking in centimeter and millimeter. So there are markings of centimeter and millimeter on it. Okay, easily be carried in pocket or toolkit. So it is quite friendly, you can carry anywhere because it's small. It is easily carried in a pocket. It is available in various length, says 1 millimeter means this is the length, this is a type of the measuring tape. It could be of 1 millimeter, 5 millimeter, 10 or 50. So these are the, just you can see, might you have seen this kind of tapes, because when you go to the give your measurement to the tailor, they are used to this one. Even the mistris are working at your homes, you will see carpenters, they use to this tapes. So these are the different shapes and structures we have, and the different lengths of the tapes are measuring tapes are available. So likewise we can with the help of this we can measure it. Like suppose that we have two places like A and B, and this is a shape of curved, so we can use with this tape we can fix over there, and with the maximum value minus minimum value we can do. So like suppose that we have fixed at 5 and 8, so what is the length? So simply we can subtract 8 to 5 and we will get this the length, because this is which kind of shape, this is the curve shape. So for the curvy shape also we can measure with this. Then after this is one of the example, as I said, that measuring the length of trouser by the tailor using the measuring tape. So there also you can use. So these are the use of the measuring tapes. So for the measurements, for the measuring the length, what is the length is the distance between 2 points, right? So to measure that 2 points distance, we are using two devices. First one was the meter rule and second was the measuring tape. So that's about the measuring tape. It is over. Now we'll see the next topic, which is our next topic, which is the measurement of mass. So this is the another SI unit. This is the another type of SI unit, mass. We have completed the length, the SI, the basic unit length we have completed. Now so we have entered to the second one, which is the mass. As you know that we have what are the basic SI units, right? Basic quantities we have. Basic quantities, actually what are the basic quantities? Length, mass, time and temperature. So one of the basic quantity, length, we have finished. Now we are in the second type, which is the mass. Mass of a body is the quantity. Mass of the, what is the mass? The mass of a body is the quantity of matter contained in it. So to make it understand, any shape we have, so as you know that matter, the first chapter we have discussed, matter which has the mass and occupies some space. So it has a surely, so how this has it has a quantity of matters. As many matters will be there, so this mass will be increased according to the matter, or based on the matter is the mass depends upon the matter. So now the mass of a body is the quantity of matter contained in it. That's all. So the SI unit of mass is kilogram. In short we used to write kg. Okay, so in the short we used to write the kg. So we have the standard one. So as you know that to accept any this SI units measurements, we have some standard one of the standard rules we have, that is the standard things that we had made, and we are following based on that. So in the 1989, 1 kilogram was defined as mass of a cylinder of platinum iridium alloy kept at International Bureau of Weight and Measures at Sevres near Paris. So that alloy was platinum iridium alloy, and it was kept in Paris, and it was done in 1989. So there was called, this is the 1 kg, and that was for the reference we have, based on that we means like equivalent to that, or equally exactly the same what we call measuring weights we have made, and we are following particular weights that we have decided over there, that is the reference one. So however, at present the mass of 1 liter is equals to, that is 1000, this is to measure the liquid of water at 4 degrees Celsius is taken as 1 kilogram. So now as you know that might be climates will change, these things whatever they have made that can be destroyed. So likewise, as earlier you have seen in the case of length, so length was just that given the fraction of like 1 by 3 into 10 to the power 8 second. Within the during that time the light travels as many distance, that will called 1 meter. So similarly here it was which like the first one, that is the physically it was made. Secondly, the mass of 1 liter, the mass of 1 liter, okay, the mass of 1 liter equals to 1000 ml of water kept at 4 degree Celsius is taken as a 1 kilogram. Means whenever you are taking the how much water, 1 liter of water, and it is kept at 100 that is that is 1 liter is equals to 1000 ml, and it was kept at 4 degree Celsius is taken as 1 kilogram. So there are some multiples like the bigger unit, the smaller unit. Some of the bigger unit is quintal. So 1 quintals have 100 kilograms, 100 kg. A smaller unit like we have a more bigger units which is the metric tons. So 10 quintals makes 1 metric ton. So 10 quintals is the 10 quintals is a 1 metric ton. So it means 1 metric ton 10 quintal equals to 1000 kilograms, right? For this we have a small unit, we have a gram, okay, that is denoted by G. So like 1 kilogram equals to 1000 gram, 1 gram equals to 1 by 1000 kilogram. Likewise for the we have a milligram for the smaller unit, right? So 1 milligram is the 1000 part of gram or 1000 milligram, that makes 1 gram. So 1 gram equals to 1000 milligram, or 1 milligram equals to 1000th part of gram, right? So this is the about the mass, and these are the units that we use. So here are some units are given. This is your homework. You have to write in your copy and you have to learn these values, like 1 quintal equals to 100 kilogram, right? 1 metric ton equals to 10 quintal, which is the 1000 kilogram. Some like kilograms. Now we have for small units grams, 1 by 1000, like milligram, 1 by 1 milligram equals to 1 by 1000 gram. So these things you have to write in your copy and learn. So other type of system we have a foot, FPS, CGS. FPF is a foot, F for F, that is for foot, P for pound, or S for second. So that is one of the system. Other system is your CGS, centimeter gram second. So what is the relations of these two, that we'll see here. So that is the 1 gram equals to 1 by 1000 kilogram, and that is value is 10 to the power 3. And this is 1 lb. Lb is actually denoted for pound. Lb is for the pound. Lb is denoted, this Lb is the pound, okay. So this 1 pound equals to how many gram? 453.59 grams, okay. So devices. So what are the devices that we use? So we have 2 devices here, means to measure the mass devices. What are the machines that we use to measure? First is the beam balance, second is your electronic balance. So beam balance is very popular one, as you have seen, is the use of beam balance. As you can see here, this is the beam balance. This is also called tarazu, something like that. So here is that one side you can keep to your like a standard weight, and one side keeps the things which is to be measured, and this pointer will indicate. Suppose pointer will go this side, this side will is more, pointer will move this side is more. If exactly at center, it means both sides is equal. So we are using this this machine. This is called beam balance. This is called the beam balance. To measure this, we have some standard weight. What are the like 20 kg, 10 grams, 5 grams, 2 kg, 1 grams. These are the things that we use to measure the our things, okay. So these are the referenced one, and for the beam balance we can use this some standard weight used to measure the mass. So then after we have some more other type, like see that this type of things you have seen in the like grocery shops, like when you just buy the vegetable, pulse, rice, sugar, they use this kind of machines to measure it, okay. Sometime you have seen this kind of even in our physics lab also this is available. This is generally used by the goldsmith for the very accurate measurement. For the small things we use this one, this balancing. Okay, so this is the also one of the machine that to measure the mass, right? So second type is your, and these all are the physicals one, they it okay. And next is your, this is called physical balance, this is called groceries balancing. Okay, next we have use of electronic balance measure the mass of the object. So we are using the electronics measurement machine by the help of by the help of like electricity or batteries it will work, and this is very accurate. Okay, nowadays very precise and accurate measurement of mass of electronic balance is used. They are available to measure small mass of 1 milligram as well as large mass also, like in a quintals. Likewise we can measure it. So as you can see, this is your electronic balance, this is your electronic balance, and it has a three basic parts. Electronic balance has this three basic part. First is your the structure, the load cell, the signal conditioner. So first is the structure. It is the load bearing part which transfer the load to the object to the load cell. It means this is the one of the load bearing part which transfer the load of the object. So whatever the load you are giving here, okay, this load will be transferred. So this work is only whatever the load is here, you just transfer it, and it will transfer to the load cell. It will convert the load, okay, that is called force. Load means whatever the object you have kept over there, that force will be transferred to the load cell, and it will convert into the which signal, electrical signal. Okay, then after this will come to the this signal conditioner, and here it is the electronic part which possesses the electrical signal and physical mass. Okay, so here this electrical signal will be converted in this signal coordinators, and here this signals will be converted to the what is the actual mass. These signals will be what is called calculated, what is the mass. According to that, there is a softwares are installed, so that will display what is its weight. So that reading you can see over here, so whatever the reading is there after this conversions. Okay, so electronic balance measure the mass automatically without any prior setting or using the separate weight box. They directly measure the mass of object and display it digital form of the screen. Okay, so this is the end of this particular standard unit, which is the mass. So in the next class we'll see about the time. So your homework is to write down all these units, what are these units are there, these are the multiple units and its a value. You have to write in the copy and learn about it. Okay, so the next class we'll see about the measurement of time. Okay, so thank you.